Welcome, ladies and gentlemen. Today we're going to be taking a look at the second video as we continue with our decomposition of fractions, and we're working with option 1, systems of equations. We're going to start with the fraction that we had to begin with, and we're going to always, in both methods, start by factoring the denominator into what two factors made it. Because I have two factors, I'm going to go ahead and I'm going to have two fractions. And I'm going to put my first factor in the denominator of the first fraction and the second factor as the denominator of the second fraction. Now, with decomposition of fractions, if I have a linear term in the denominator, the numerator is always 1 degree less and will therefore be constants. Now I'm going to get the common denominator, x plus 2x minus 4, which means I have to multiply the first fraction by x minus 4, or the denominator of the second, and then I'm going to multiply the second fraction by the denominator in the first. Notice that I will now have the common denominator in all three fractions, and I can now work with just the numerators to continue and proceed. Now always put a plus in between your fractions. If we end up having a negative, that negative will be self-evident at the end. I'm going to distribute the a and the b using the distribution property. Negative 2x minus 10 is equal to ax minus 4a plus 2bx plus 2b. And you'll notice that these two terms are going to make my linear term, and these two will make the constant term. And that's how we're going to gather them. So let's put them together as negative 2x is made by ax plus bx, and this quickly factors into negative 2x is a plus b times x, and I am now able to find my first equation in the system. Negative 2 is a plus b by dividing both sides by x. Working with the constant, I have negative 10 is equal to negative 4a plus 2b, and this becomes my second equation in our system of equations. I now have the choice of using linear combination or substitution. I'm going to be doing linear combination and multiplying by my first equation by a negative 2 so that the b's are opposites, and I end up with 4 equaling negative 2a minus 2b, and negative 10 is equal to minus 4a plus 2b. Combining the two equations, negative 6 is negative 6a with the b's canceling. I can see that 1 is equal to a. By back substitution in my first equation, I can then solve for b and find that my b term is negative 3. If you recall, ladies and gentlemen, putting them back in, we have 1 over x plus 2 minus moving the negative into the front. This had the minus 4. And if you recall, that was our original sum and difference that we had. And this is our first method, using systems of equations. Thank you very much, and I will go to the second option in the next video.